Mathematics in our world. Topics: patterns and numbers in nature and the world, the Fibonacci sequence, mathematics for organization, mathematics for prediction, mathematics for control, and mathematics is indispensable. Patterns and number in nature and the world. Mathematics is a science of structures, order and relation that has evolved from elemental practices of counting, measuring, and describing the shapes of objects. Many patterns and occurrences exist in nature, in our world, and in our life. Math helps make sense of the patterns and occurrences. The father of mathematics is Archimedes. Patterns in nature are visible regularities of form found in the natural world and can be also seen in the universe. Nature patterns are not just to be admired, they are vital dues to the rules that govern natural processes. Patterns define us: regular, repeated, recurring form or designs, identify relationships, find logical connection to form generalization, and predictions. Here are some examples of patterns in nature. Types of patterns: symmetry, bilateral symmetry, radial symmetry, reflective symmetry, five-folded symmetry, fractals, spirals, tessellations. Fibonacci sequence, also known as Leonardo-Bonacci, Leonardo Pisa, or Leonardo Bigiolo Pisano, was an Italian mathematician from the Republic of Pisa, considered to be the most talented Western mathematician of the Middle Ages. Fibonacci sequence was discovered after an investigation on the reproduction of rabbits. Simple rule: add the last two to get the next. Mathematics for organization. We need mathematical tools to help us make sound analysis and better decision. Example: scientists can plot bird migration to help conserve endangered animal population. Mathematics for prediction. We can use mathematical models using existing data to generate analysis and interpretation. Example: weather and astronomers use patterns to predict the occurrence in meteor shower. Mathematics for control. Through the mathematics, man is able to exert control over himself, the effects of natures. Mathematics is indispensable. The study of mathematics should be embraced as it paves the way for more educated decisions and in a way bring us closer to understand the natural world.
Mathematical language and symbols. Language of mathematics. The system used by mathematicians to communicate mathematical ideas among themselves, and distinct from natural languages in that it aims to communicate abstract logical ideas with precision and unambiguity. Characteristic of mathematical language. Precise. Mathematical language is able to make very fine distinction or definition among a set of mathematical symbols, unlike in ordinary speech, which is full ambiguities, innuendos, hidden agendas, and unspoken cultural assumptions. Concise. It means long expositions or sentences can be expressed briefly using the language of mathematics. Symbolic. It means mathematical language can describe a subset of the real world using only the symbols. Powerful. Mathematical language is able to express complex thoughts with relative ease, devoid of emotional content. It means there is absence of emotion from formal mathematical discourse. Non-temporal. It means there is no past, present, or future in mathematics. It is not affected by time. Common mathematical symbols. These are the symbols that we usually use in solving mathematical problems like addition, subtraction, division, multiplication, and other mathematical symbols that commonly used. Expression versus sentence. Expression. An expression is the mathematical analog of an English noun. It is a correct arrangement of mathematical symbols used to represent a mathematical object of interest. The most common expression types are numbers, sets, and functions. Sentence. A mathematical sentence is the analog of an English sentence. It is a correct arrangement of mathematical symbols that states a complete thought. A sentence can be true, false, or sometimes true, sometimes false. For example, the sentence 1 plus 2 equals 3 is true. The sentence 1 plus 2 equals 4 is false. Mathematical convention. A mathematical convention is a fact, name, notation, or usage which is generally agreed upon by mathematicians. 4 basic concepts. Sets. A set is the representation of a collection of objects, distinct objects with one or more common properties. 3 ways to represent set: in statement form, roster form, set builder form. Relation. A relation is any sets of ordered pair numbers, the couple pairing, and the pairing of the student's name and the courses taken are example of the relation. Function. A function is a relation in which no two ordered pairs have the same first element. A function associates each element in its domain with one and only one element in its range. Domain. It is a collection of a first value in the ordered pairs. Range. It is a collection of the second values in the ordered pairs. Binary operation. A binary operation on a set is a calculation involving two elements of the set to produce another element of the set. Addition, subtraction, multiplication, division, exponential is some of the binary operation.
Problem solving and reasoning. What is problem solving and reasoning? As I mentioned above, problem solving reasoning is a trisection under logical reasoning which involves solving problems by performing various mathematical operations. Important topics that came under problem solving reasoning are inequality, analogy, series, puzzle, and so on. Inductive and deductive reasoning. Inductive reasoning is the process of reaching a general conclusion by examining specific examples. Deductive reasoning is the process of reaching a conclusion by applying general assumptions, procedures, and principles. Intuition, proof, and certainty. Intuition, the ability to understand something instinctively without the need for conscious reasoning, Aruganda 2014. Proof defines a statement to be true in a quantitative measure using logical reasoning. Show a statement to be true using definition, theorems, and postulates. Certainty. Mathematical knowledge consists of those mathematical propositions that are objectively warranted as true or logically valid and can be claimed to be known. Problem-solving strategies. Strategies are things that Puglia would have as chose in his second stage of problem solving and used in his third stage. Mathematical problem involving patterns. Patterns are defined as a repeated occurrence or as something that follows a specific rule. We can use patterns to solve math problems in a number of ways. Two steps that are always involved in solving problems using patterns are as follows. Identify patterns that your data seems to take on. Puglia's fourth step in problem solving. Understand the problem. Devise a plan. Carry out the plan. Review the solution. Example: a baseball team won 2 out of their 2 last 4 games. And how many different orders could they have to wins and 2 losses in 4 games? Understand the problem. There are many different orders. The team may have won 2 straight games and lost the 2. Win-win, loss-loss. Or maybe they lost the first 2 games and won the last 2. Loss-loss, win-win. Of course, there are other possibilities such as win-loss, win-loss. Devise a plan. Make an organized list of all possible orders. Carry out the plan. Win-win, loss-loss. Win-loss, win-loss. Win, loss, loss, win. Loss, win, win, loss. Lost, win, lost, win. Lost, lost, win, win. Review the solution. The list has no duplicates and the list considered all possibilities. There are 6 orders, in which baseball team can exactly 2 out all 4 games.
Data management, the science of collecting, organizing, presenting, analyzing, and interpreting numerical data. Refer to the mere tabulation of numeric information in reports of stock market transactions of the body of techniques used in processing of analyzing data. Data gathering and organizing data, representing data using graphs and charts, interpreting organized data. Data can be collected using observation, interviews, questionnaires, and accessing database. The method chosen for collecting the data depends on the type of research being done. Organizing data is bringing them together in a systematic way that makes it easier. Ernest Tucker. Measures of central tendency mean median or weighting. The tendency for set values to gather around the median of a set generally measured by median. The arithmetic average. This is used for continuous data. Median, a value that splits the data into the 2 halves, that is 1/2 of the data smaller than number of other larger, may be used for continuous or ordinal data. Measure of dispersion range, standard deviation, and variance. Measure dispersion is described the spread of the data. They include the range, interquartile range, standard deviation, and variance. The range is given as the smallest and largest observation. This is the simplest observation. This is the simplest measure of variance. Measures of relative position, z-scores, percentiles, quartiles, and box and Whiskers plots. The common measures of relative standing or location are quartiles and percentiles. A percentile is a measure used as statistic indicating the value below which a given percentage of observation in a group of observation. A z-score indicates how many standard deviations a data point is from the mean. It is calculated with the following formula, where x is the value of the data point. A percentile indicates the relative standing of a data value when the data are started into numerical order from smallest to largest. 50% of data values are less than or equal to the mean. The percentage, for example, 15% of data values are less than or equal to the 15 percentile. Probabilities and normal distribution. The normal distribution is the probability distribution as with any probability distribution. The estimates the probability that a value will fall within that interval. Linear regression and correlation, least squares line linear correlation coefficient. A correlation analysis provides information on the strength and direction of the linear relationship between two variables, while a sample linear regression analysis estimates parameters in a linear equation that can be used to predict values of one variable based on the other.